Okay, hello everyone. Today we're going to be solving Geeks or Geeks problem of the day. Make array elements equal. So we're given an integer n, and we have to consider an array consisting of n elements, where each element will be 2i plus 1. The array is 0 next. Okay. Now we are allowed to perform the following operations on the given array any number of times. Select the two indices I and j and increase area of I by 1 and decrease area of j by 1. The task is to find the minimum number of such operations required to make all the elements of the array equal. Okay, let's understand the test cases in MS Paint. Okay, so n is 3. If n is 3, our numbers would be 1, 3 and 5. Because of 0 indexation, 2 into 0 plus 1 is 1. Then 1 at index 1, 2 into 1 plus 1 is 3. And then at finally 2, 2 into 2 plus 1 is 5 at index 2. Now if I had to make all these elements equal, what I would do is uh, the best thing would be to make them all equal to their mean. So I would sum all of them and make it equal to the mean. That would be 9 divided by 3 is equals to 3. Let's look at another test case. And then I would decrease 5 by 2 and increase 1 by 2. Okay, yeah. And since we can increase and decrease them in the same operation because they are at equal spacing from 3, that means in one operation I would increase 1, decrease 5, and then again increase 1 and decrease 5, then finally we'll get 3. So two operations are required. Let's look at another test case. Let's say n is 7. Then our numbers will be 1, 3, 5, 7, 9, 11, 13, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5 and 6. Okay, now again I would take the mean of all of these elements. So 1 plus 3 is 14, 11 plus 3 is 14, 9 plus 5 is 14, 42 and 7, this gives 49, and divided by 7, that should give me 7. So okay, let's take a look at the final test case now. Let's take a look at 9. For 9 I'm just adding two elements here, that is 15 and 17. So in this case the mean would come out to be this is 6, 7 and 8. So the mean should come out to be wait a second, middle element. So I think it is pretty clear that the value to which we have to make all of the elements equal will always be the middle element. In the case of 3, it was at index 1, which is 2 divided by 1. In indexes it was 7, and in index 8 it will be 9. You can check it, it will be 9. Okay, so now what let's look at another test case. What if n is even and it is 8? Then up till 15 so I have to take the elements. Then in that case what would be my mean? Let's see, up till here it was 49 plus 15, 64 and 8, 8, right? And I have to make all of the elements equal to 8. So 8 minus 1, I would again all of the elements present, if I am making all of the elements equals to some element, there will always be two elements, such that you have to increase x to get that number and decrease x to get that number. For example, if n is 8, I have to increase plus 7 to get 8 and decrease minus 7 from 15 to get 8. Similarly, I have to increase plus 5 to get 8 in 3 and minus 5 to get 8 from 13. Similarly, plus 3 and minus 3, and then in 7 it will be plus 1, and for 11 it would be, for 9 it would be minus 1. Okay, so now I will show you something which is really cool. This problem might look to you like it's some somewhat like a O of n solution, but that is not it. You don't actually have to find the element which you want to replace it with. All you have to do is just look at the test cases. If you have observed carefully, you would be able to see it. So, for let's say if my n is even, n is even. Sorry for my bad handwriting. Now, if n is even, we had to make elements. For example, it was 4, 1, 3, 5, and 7. The middle element, 7 plus 3 is 8, 8 plus 8 is 16, so we have to make it equal to 4. Now, the difference are will be in the order of 5 minus 4 is 1, 7 minus 4 is 3. So you can see all of the elements will be somewhat like 1 plus 3 plus 5 dot something something so on, and you have to take the sum of all of these elements, and this is basically like 2 into I minus 1 sigma, and up to what? So if you see, 3 is nothing but n is even and n was 4. So, and the maximum difference up till it was taken was 3. So that means n by 2. That means you have to take the sum of all of these elements from index 1, I is equals to 1, to n by 2. Okay. Now what is the sum of all elements from 1 to n? That is nothing but n into n plus 1 by 2. And what is the element of all of the elements from 1 to n? That is n. You multiply it with 2 and then you get n squared. So the answer is n squared, where actually it should be n by 2 squared. Okay, so if the answer is 4, then it would come out to be 2 squared. Let me show you. So if answer is number n is 4, then you just divide by 2, you get 2, you square it, and the answer should be 4. Let's see if it is correct or not. So if 5 minus 1 is 4, so plus 1, 7 minus 5 4 is 3, so plus 3, and answer is 4. Okay, now what if the elements are odd? If the elements are odd, then it would be something like, let me erase this first. Okay, if the elements are odd, then it would be something like 1, 3, let's say n is 5, 7, 9, and 11. Then I would make all of the elements equal to 7 in this case, and the differences between the adjacent element would be of the form 2 plus 4 plus 6 up to so on. So this is nothing but sigma 2 into I, and if you look at the largest sum, say let's say if this is 5, it would extend from uh, the maximum element in this case was 4. So this is nothing but n by 2 again, floor of n by 2 to be more precise, and I is equals to 1 to n by 2. So that some of the elements again here would be 2 into n by 2, uh, n n plus 1 by 2. So this is nothing but n squared plus n. So for odd elements, uh, this is n is odd. So now you have seen that for odd elements, answer is n square plus n, and for even, our answer is nothing but n squared. So let's code it up. This is pretty simple to code, and let's take answer is long ans is equals to 0, and n has to be divided by 0, divided by 2, sorry, in each case. But before that, okay, let's take another variable. Let's take n is equals to n divided by 2. Now if n is odd, there is a very nice trick of seeing if n is odd, that is n and 1. If n is odd, then what was our answer? Let's see. If n is odd, our answer was n squared plus n. Then just return n. Let's take 1 LL, because if the n is 1e9, then it can go out of bounds, into n plus n. Wait, return answer is equals to, else the answer is equals to 1 ln into n into n, and let's just return answer. I think they should be correct. Maybe if I'm not swapping them, like even or if I'm not swapping them, then this answer should be correct. Oh god, why is this taking too much time to evaluate? Okay, let's take custom input before we are sure. Let's take n is equals to 13. For 13, n is odd. That means yeah, n squared plus n. And let's try to submit this. Okay, all tasks are passed. Thank you for